Hello, and welcome to Automating Your Lab using Green Button Go. My name is Ahmad Mansour. I am Director of Customer Success at Biosero, and I'll be moderating today's event. This is the last in a webinar series focused on tactics and strategies for implementing lab automation. And of course, we will be talking about Green Button Go scheduling software. Today, we have a blue ribbon lineup of speakers, starting with our Chief Technology Officer, David Dambman. David will be talking about how to take the data coming out of your lab and putting it in the context of the strategic aim of your workflow. Afterward, we'll hear from Eli Lilly on how they use Green Button Go to streamline their lab and their data analytics. After the presentations, and if you have the time, please join us in our Zoom meeting room where you can meet David, Ryan, and Kaveh to delve deeper into your questions around automation. Before I introduce David, however, a couple of housekeeping items. If you have not already, If you have not already, please participate in the poll that is posted on the right side of your screen. With all of us working from home, you've probably attended several webinars in the recent months, so you know that you can post questions at any time, and we'll follow up with answers at the end of each presentation. Also, feel free to use the chat box to share ideas and interact throughout. With that, I'd like to introduce David Dambman, Chief Technology Officer for Biosero. David leads the software and integrations teams and sets the vision and direction for Biosero's future software projects. David's leadership has contributed to the development of numerous software products, including Green Button Go. Take it away, David.
Hello. Thanks for taking the time to join us today. I really appreciate the opportunity to speak with you, and I'm really looking forward to interacting with you all during the discussion time afterwards. Also, thanks to Ryan and Kaveh from Eli Lilly. We really appreciate them joining us today, and I'm really excited to hear their presentation. All right, so I wanted to start off with a brief mention of Biosero's mission. So at Biosero, our mission is to provide software that enables everyone to use automation successfully and with ease. We believe the integration of automation software and advanced analytics will provide superior results in an evolving world. So I wanted to frame this presentation in this way because although the focus of it is on data, the thing that really drives us at Biosero is being part of the amazing work that our customers are doing. As you strive to impact the world through discovery, we're constantly working to provide you with the tools that unlock and enable the constantly evolving technologies that really make that discovery possible. All right, with that in mind, let's jump right in and start talking about data. So I'm going to start talking about the benefits of automation and data integration. And then we're going to move through sort of talk about the categories and types of data that can be captured and some use cases for that data. Then we'll talk through sort of what metadata is and how data can be contextualized. And then we'll finish it up with some discussions about the tools that Biosero has to capture, contextualize, and manage that data. So I'm going to start off at first talking a little bit about automation and integration. So these are both tools for improving your workflow, but automation is specifically the process of setting up a system to run with reduced need for human assistance. Whereas integration is about connecting disparate systems together to enable data to flow and samples to flow between them. This distinction is important, especially for manual workflows, because you can still benefit from integration even if you're not going to apply robotic automation. So let's look at some of the benefits. All right, the most obvious is throughput and scale. Automation can run 24/7, overnight, over the weekends. The scale can be thought of sort of in two different ways here, right? Once you're automated, it's easy to increase your throughput by simply scaling up, buying a second system, a third system, etc. But scale can also be scaling down. If you change your assay volumes to use fewer reagents, right, you can scale down from 96 well plates to 384, 1536, or even further. So automation provides the ability to scale down in those ways that both provide cost savings as well as increase in throughput and allow the sort of assay miniaturization, and can operate really at a scale that human beings aren't capable of. Another key benefit is walk-away time. Right? Automation allows you to spend a lot less time on tedious, repetitive tasks and frees you up for more knowledge work, for more important and impactful work. It also has the added benefit of really lowering the rate of repetitive stress injuries. Next is data and sample integrity. Right? When your data is integrated and the transfer of data is automated, you're a lot less likely to browse for the wrong work list or lose that flash drive. So there's a tremendous reduction of human error that can be achieved, as well as a level of consistency, especially sort of in handling the data, and handling the samples. Right, everything is processed consistently from run to run. Finally, there's insight, traceability, and reproducibility. So automation and integration can generate really rich contextualized data sets. This allows everything from real-time sample tracking to audit trails and chain of custody, but also analysis that can focus on things like resource utilization, costing, and return on investment. It also really helps with consistency and better reproducibility. So as we look at these, we see that the top two are really in the domain of automation. Right? These are about the way that that robots can be applied to your workflow to help you. But the second two are really more about integration. This is about how the data can be gathered and connected through your process. This is what I like to call the automation continuum. Right? We have workflows that start on the left side, sort of purely manual, right? And then continue up. It's sort of increasingly automated to these sort of semi-automated workflows that you have, instruments executing multiple steps, but still require a lot of human interaction, loading and unloading plates. Up to sort of automated workflows that are, whether it's mobile robots connecting instruments in the lab or work cells where the instruments are arranged around a robotic arm to process the samples and move samples from one instrument to another, to really fully automated lights out automation that can run for days with little or no human interaction. The key here, though, is that regardless of your level of automation in your lab, there's tremendous value to data integration. So let's look at what can be achieved through better integration. What kind of data can be captured? What categories of data there are? What value those have to us, and what are the tools that we can use, and that Biosero can provide to help you make use of that data. So here we have really an oversimplified pictorial representation of a drug discovery workflow, and as you can see, it contains a lot of different types of steps in the process, from sort of manual, compound weighing, to semi-automated to fully automated steps. Now, there's a tremendous amount of value in the data generated from a process like this, but it's often siloed, whether it's in log files on an automation system or on an instrument, or notations in a notebook, or just simply not captured at all. The samples are often moved to these processes by people in an unscheduled manner, and with very little thought to sort of integrating this at a higher level. So without proper integration, the focus from the data in the system is usually on two things, right? It's the sample data coming into the system and the experimental data coming out, right? So all of the additional data that is generated through the whole process is usually ignored and really can't be mined for its value and its ability to enhance the process and enhance and explain the experimental data, as well as provide additional insight into the process itself. So let's look at how we can categorize this data, as well as understand the value of it and how we can make use of it. I like to add three categories to our existing sample and experimental data, and that's process and workflow data, instrument operation data, and environment data. So this slide contains a small sampling of the types of data for each of these categories. I'll focus on these center three to look first at why we'd want to capture that data, their uses, and then talk a bit about metadata and how data can be contextualized to enhance its value. So first the why, then the how. So what is process and workflow data, and why capture it? So this is stuff like the sequence of events, the timing, what are the individual parameters of every step, instrument allocation, what instrument was it done on, what was the intended the intended instructions versus what actually happened, and can contain everything from the labware used, different types of consumables, or even the user, who's the operator of the system. So by capturing this process and workflow data, right, you can ensure that your process was executed correctly and reduce errors by minimizing human input and the friction of the whole process operating, right. Capturing timestamp data events can really help determine the consistency across each sample in the process, and really help you determine if there's variability that might be attributed to specific instruments, or can affect the the experimental data output. So being able to sort of correlate those, correlate the process and operation steps to the experimental output, can really give you great insight and valuable feedback. So instrument operation data, on the other hand, is really all about instrument utilization. Right? It's the conditions, the configuration of that instrument, how they were used, if there were errors or failures on that instrument, things like maintenance and calibration data for those instruments, and this can extend up to work cells as well as a whole. And the key here is really that this gives you insight into exactly how those operated. And the real golden goose that you're pursuing here is predictive analytics, right? The ability to predict failures and prevent costly unplanned downtime. So, without capturing exactly both the operating conditions of those instruments, and how they were utilized, and what what all the different data coming off that instruments is, that won't be achievable. In addition to those sort of deeper insights, that we might be able to gain, there's the really sort of utilitarian goal of being able to look at just utilization. Right? If you have shared resources, you need to know who is using them and when and how often they're being used. Right? So this can allow you to better budget for future needs, to really calculate the ROI you have on these. The investment into these instruments, and it allows you to schedule maintenance based on use rather than on sort of a fixed time period. So again, that can help do things like reduce failure rate, and lower the cost of the operations of that instrument. So when considering environmental data, things like temperature, humidity, light, vibration, air particle count, or even incidentals like the electrical power conditioning or air pressure. There's a lot of things that you can look at, and the idea here is that we'd want to be able to correlate that data with the experimental results, right? To see if there's any effect that those environmental conditions may have on your assay, especially if there's, particularly sensitive assays. Being able to monitor those also gives you the opportunity to, to warn you if the conditions might be outside of range for that particular assay anyway, so that you can sort of preempt a problem occurring. So once we see why this data is so valuable, it's really important to talk about how we capture it. And this is really all about metadata and contextualization. So metadata is data that describes or provides information about other data. So when you capture a temperature, you need to know something about it, right? What instrument it was recorded on, when it was recorded, etc. Contextualization then is really identifying and associating other relevant data and important data in order to make that data more useful. It's that data in aggregate within its context that really provides its value. So being able to really properly capture and contextualize data is key. So I think the importance of this can really be highlighted with the data information knowledge wisdom pyramid. Right? So using our temperature example, the raw data of a particular temperature that's captured is practically useless unless you can really add the meaning and context to that. So right, if you know that temperature is associated with a particular incubator at a particular time, that provides additional value to that data, right? Going one step further and knowing that sort of in context that temperature reading is outside of its normal range increases the value even more and really provides what you need to apply that data. This is the wisdom part, right? And this is where AI and ML can come in, is that you need to be able to make decisions based on that data. So right, given that context, that, okay, we need to maybe call a service tech and notify the scientist of a likely assay failure because of that incubator having its temperature out of range. So again, that knowledge generated from the past can be acted upon in the future. And again, the better contextualized that data is, the more comprehension and value that data has. As sort of a side note, one of the problems that I see is that often there's a lot more investment into the sort of AI ML side of of data processing, the analytics, and not enough is invested in really the hard work of capturing and properly contextualizing that data. Right, the analytics is focused really just on the experimental and sample data, and doesn't take into account the context, because really most companies really haven't captured that data properly. So this next slide really illustrates Biosero's data contextualization strategy. So, and this is how we get from raw data to information and knowledge. Right. Data comes off of the various instruments and devices and sensors, right? And through the through Biosero software, Green Button Go, Lab Experience, etc., we can provide the local context initially for that data. So, right, an instrument may know nothing about what order this is part of, right? Who the user was that set up this run, or what model of pipetters being used. And so we can bring in that local context at that level, right? And then as we publish that data, we can provide the larger sort of group and organization context, right? This can deal with things, as far as even, data policies, sharing policies, retention policies, etc. But also provide really the why, the for whom, the idea of ownership in that process. stream processing that can provide, for instance, the costing calculations to any of the consumables being utilized in that process. And then from that sort of group and organization context, we can provide sort of at the storage and analytics part, that global and historical context to that data. So as you're looking to integrate your data and to automate your processes, please reach out to Biosero. We'd love to show you in more depth how each of the products in our Green Button Go Enterprise Suite can really help you, in all of your processes, all the way from your manual operations, that can be controlled with lab experience through, semi-automated, automated, or full lights-out automation. We have tools that can really connect all your disparate systems together and help integrate your data and manage your automation needs. So on your road to discovery, as you're puzzling out the cure, we really want to be a part of that, right? And we believe that Biosero's technology stack and our software platform has a tremendous value that we can provide to really help you in your efforts to make the world a better place. Thank you.
David, that was great. Thank you very much.
Thank you, everybody.
All right, so we'll go to some questions. We have a couple here already for you. Does GBG support retrieval of historical data while the data is being collected?
Yeah, so every run in Green Button Go generates a tremendous amount of data. Some of it's stored in the local database or generated in reports at the end of each run. And it can be connected and easily integrated with really any data system that you have, right? So we can, whether it's using our data services integration or direct connection to your LIMS system, we can stream or provide really a wealth of data about your processes.
Okay, great. And then second question is, how does your solution get deployed at our site?
Yeah, so that really depends on what your needs are. We often will build up an entire work cell and deliver a fully functioning system to our customers. But there's other customers that simply download our software, install it themselves, and can get up and running. So really, depending on your needs and your in-house bandwidth and engineering capabilities, we can come alongside to really help at every level.
Okay, great. Thank you very much. That was a great presentation, great appreciation. Thank you again.
Thank you.
So before we continue with our talks, let's take a look at some of the poll results. So for the question, what data formats are of interest to you? We have a fairly even distribution. Imaging files is at about 21%, barcode IDs 24%, graphs 26%. Tabulate is at 11%, and spreadsheets are at 18%. And what is the pain point around data in your routine work? Yeah, this one's probably a pretty obvious one. Too much data is at 55%, and confusion on data at 33%. And how is your data stored? Well, thankfully, local PC only came out at 8%, the majority being company network drive at 67%, and cloud deployment at a nice 25%. And then how are you gathering your data? For example, sample ID, microplate label, assay name. And so we have manual entry key via keyboard stroke, 31%. Lab journal or handwritten entry at 15%, and automated systems at 54%. Okay, great. So let's continue with the presentations. I'm very happy to introduce Ryan Bernhardt and Kaveh Saramount from Eli Lilly and Company. Ryan is part of the Discovery Automation Research and Technologies Group at Eli Lilly and Company in Indianapolis. leading a team of automation engineers and scientists in the design, implementation, and operation of a variety of innovative automation projects across Lilly's R&D labs. During his time at Lilly, Ryan has also contributed as the automation architect and integration leader for the Lilly Life Sciences Studio, also known as L2S2, the state-of-the-art fully automated drug discovery platform. Ryan received Lilly's Top 100 Innovator Award for his track-based modular design of L2S2, which incorporates a multi-level scheduling software infrastructure. Prior to joining Lilly, Ryan worked for Hamilton Robotics as the global business unit leader for emerging automation markets. Kaveh is the QC lab robotics lead in Eli Lilly's global robotics program in Indy. He has been working to develop and deploy validated robotic equipment for the execution of routine quality assays in the pharmaceutical manufacturing environment. He supports a global manufacturing infrastructure spanning the United States, Europe, Asia, and the Caribbean. Current projects include a fully automated platform for endotoxin testing and bioassay testing, as well as sample management systems interfaced with autonomous vehicles for the delivery and management of production samples. So without further ado, I give you Ryan and Kaveh of Eli Lilly.
Hello, everyone. My name is Ryan Bernhardt. I'm the Discovery Automation Group Leader at Lilly, and I'm here with my colleague Kaveh Saramount, who is the Manufacturing Quality Control Lab Robotics Lead at Lilly. And we'd like to thank you very much for your attendance today, and we'd also like to thank Biosero for the opportunity to present at this webinar. We're very excited today to talk to you about how we are leveraging Biosero's Green Button Go software to streamline process performance and data integration across Lilly's R&D and manufacturing environments. I want to start out briefly by giving an overview of the breadth at which we're leveraging Biosero's GBG software across the research and development space here at Lilly. We have today over 20 GBG workstations that are implemented and are running on a daily basis across multiple sites here in the US. We have systems that are simple read and feed type stations leveraging Green Button Go. We also have very, very complex integration and integration which really is the first of its kind that's using GBG to power those systems as well. And so one example of that is our preparative purification workstation, which is leveraging GBG to fully automate preparative LCMS analytical systems, as well as the loading and unloading of those. We have another analytical testing workstation that is fully automating the analytical LCMSs in that same process. We have several GBG systems that we call in-out workstations, and really they're geared around plate and sample handling, barcode labeling, sealing, desealing, getting those plates ready to enter into another automated environment. We have a number of systems that you'll see briefly that are around really automated assay work, whether it's biochemical testing, cell-based assays. We even have systems that are set up using GBG that we have in our open access spaces that are they're made simple enough where researchers are able to walk up as needed and run automated assays in an open access environment. We have GBG powering our advanced automated biology lab, which is really to fully automate and streamline enzymatic and cell-based assays that have endpoints in LCMS, high content imaging, multimode reading, flow cytometry, and that supports a variety of functions across Lilly's discovery research space. We have systems that are around colony picking, and so we have GBG controlling our QPix colony picking workstation. We have automated weigh stations, which are really geared for the weighing and the tearing of vials, as well as the weighing of final compounds that are made in our synthesis environments or in our compound management spaces. We have systems running GBG, as I mentioned, that are really read-feed type stations. They are allowing us to automate high-content imaging and multimode reading capabilities so that researchers are able to go from task-oriented to goal-oriented mindsets. And so they can load up their plates at a workstation, they can coordinate or hit go, and GBG handles the rest with robotic arms that are moving things to and from high content imagers, flow cytometers, and multimode readers. And this really frees the researcher up to do more during the day or even get this work done in the evenings. Some of the systems that I mentioned are really all geared around, these have been integrated by Biosero to leverage Green Button Go. Now I want to briefly just highlight some of the systems that used a different integrator and were brought in maybe at a way earlier date into Lilly, but we've now been able to convert those systems leveraging GBG to really extend the life of some of this equipment to be able to move us from things like Windows 7 to Windows 10, and also gives us the ability to additional flexibility and capabilities as we want to add new devices and do more with a system that may have been built 5, 6, 7, 8 years ago. And so a few examples of that are we've used Green Button Go to convert LabSite's Tempo software on our Echo Accesses. So we have multiple of those conversions. We also have biocells that were running Agilent BWorks, and we've been able to convert those to now using GBG, and that's a great example of being able to extend the life of some of the devices and things that that really were at a point where there was no longer service or support on that, and enables us to add new functionality to an older system. We also took one of our cell picking systems that was built by Thermo, running Thermo Momentum software, and we converted that to Green Button Go. So we've now have the ability to add new imagers and picking capabilities as they come out to really extend the life of that, but also offer a new life and new capabilities to things that we want to do today. In addition to the systems that we've already done conversions and they're up and running in production across Lilly's R&D environment, we have several ongoing software conversions that where we're putting GBG in place. And so a few of those are the molecular biology system and an IgG quantification and picking system, both running Beckman SAMI software initially, and now those are on their way to operating under the GBG environment. And then we have a transfection system that was originally integrated by Waco using the Director software. Now this is owned by Fujifilm, but we've also brought in Green Button Go to convert that system as well. And so in addition to being able to streamline things, what we're also doing is creating an environment where we can have a commonality between different workstations, different applications, different environments, and we can leverage tools from one system to another. It also gives us the ability to more effectively support these systems as we have experience levels that are growing and capabilities that are growing as part of the Green Button Go implementation across Lilly. I also want to mention briefly is examples of where we've taken the GBG software and we've expanded that into what we call Scalable Gbg Solutions. And one of the most notable for those who were part of SLAS 2020 is in the example of the Lilly Life Sciences Studio, what we refer to as L2S2 environment. We unveiled this as part of SLAS 2020, and it's really a platform very unique, which seeks to automate the entire drug discovery process. It's made up of over 20 independent modules, but at a higher level has a scheduling software on top of that. And then the system that I'm going to focus on today as an example of this scalable GBG solution is our acoustic dispensement system, which is located at our Lilly corporate campus in Indianapolis. And this system is really serves the purpose of being able to generate assay-ready plates, whether those are independent compounds, concentration response curve with selected compounds, mixture plates, or just the creation of master plates or library or diversity sets that can be leveraged downstream by researchers and other labs. And so as you can see, this is a larger system. It's not a single workstation. It's actually a system made up of multiple workstations. And that's where I'm going to focus for the next few minutes. But before I do that, I want to go back to really 2015, and Lilly had the concept of this master scheduler. And what we were in preparation of L2S2, we were really focused on this idea that we needed an automated scheduling software that was at a much higher level. It kind of a 30,000 foot view where this scheduler acted as the air traffic control center for several independent automated workstations. So you know, some of the functionality that was needed here is this master scheduler had to be able to interface with LIMS, ELN, local databases. It needed a interaction point or portal to the outside world where people could leverage or request work to be done. And that's kind of what we call the user experience. We also, the main functionality that this master scheduler required is it needed to be able to take handle orders. So receive orders, take those orders and parse out parameters. And then based upon those parameters, it needed to be able to effectively schedule that work on cross workstation platforms. So based upon the parameters, it needed to be able to determine which workstations had the capability to handle those needs, and then effectively break that down to determine optimized workflows, and then send those parameters and send that content so those workstations could be scheduled as part of the process of the workflow. As part of that, it needed to effectively be able to integrate those workstations, or what we called modules, and so you had to have bidirectional communication there and be able to execute different scheduling software that was going to be at each workstation. So there's no standard API for every automation software that's out there. So we needed a liaison between the master scheduler and those platforms to effectively communicate. We have to be able to process data and manage data flow, and that gives us the ability to then have the scheduler automate decision making. And this is where, you know, machine learning and artificial intelligence comes in, where we need that ability to make decisions based upon what's happening in real time to improve things over time. Another key part of that was being able to do error management and automate error handling, log and communicate those errors. But on a cross workstation system, if there's one thing that we know happens is there will be errors, and so we needed a scheduling software that had the ability to effectively handle those errors so that work could still continue to get done even if humans weren't around. And then lastly, we needed the ability to visualize what's happening in the lab. We needed a platform dashboard, so be able to display what's running at any given time, what content is on which platform, how are things working, are there things in error, and so that's where we needed the capability of a platform dashboard. So Biosero's response to our concept is really what we're looking at here. And one thing I want to highlight is it's not a single software solution, but a collection of different applications that can be added or removed from the original Green Button Go architecture. And so I want to spend the next few minutes just translating how this collection of GBG applications can be implemented into a scalable system, or a system that it is more than just a single workstation for a platform or entire facility, or multiple labs across a research building or campus. And so I'm going to, in the example here, I'm going to use the acoustic dispensement system that we have here in Indianapolis. And just quickly, one of the things you can see is it's made up of 4 echo access systems. It has an in-out module that's really feeding plates in and out of the system. And it has a Hamilton Verso store automated system, which is handling the master compound collection plates and storing those. And as needed, those plates can then be sent out to the various echo access workstations for acoustic dispensing to create the assay-ready plates that our scientists are relying on to be able to do their research. And so in this example, I just highlighted the different modules or the different workstations that are out there. We also have a MagnaMotion track that's at the center of this, essentially connecting these workstations. But virtually what we have is the GBG Order Manager. And essentially this is acting as the air traffic controller. It has the ability to then plug into the Transportation Manager applet and the multi-robot service. And so we're able to leverage GBG's application to control the track, as well as to control the 6 different robots that are on the different modules as they need to be able to pick and place things from the track. The answer or the solution to how do we interface with these different modules was GBG's agent. And essentially what that is a liaison that sits between the various modules and the software that's running those in the GBG Order Manager. And essentially this agent is the bidirectional communication that standardizes the way that information goes back and forth between modules, even regardless of the API that may sit on that module, regardless of the software there. All this information then is fed back into the GBG data services, and it's available to go out to LIMS systems, but it also is available to be fed into the GBG dashboard or taken into other external programs or data services that may be relevant to your particular application or environment. And so this is just a schematic which shows the same thing I just talked about, but it's really breaks it into two layers. At the platform layer, you have the GBG Order Manager, the Transportation Manager controlling the track and the robots, and then the module agents, which essentially physically kind of represent these spurs. They're the communication between the workstations and the order manager. At a higher layer is really the data services. And so all the information that's being gathered at the platform level goes into the data services, where now you have an order interface into your LIMS system or compound inventory, or even where researchers may submit their orders. You also have the ability to query services to see how are things doing, how instrumentation are running. And you then have that data that also is part of an event stream, which can go and say, here's exactly what's happened, how many times, and then make that available in a user visualization tool, which is the GBG dashboard. So I want to just briefly showcase, what this system looks like physically, and give you an idea of how we've leveraged the same architecture, where we have the concept of highways and spurs, and what you're seeing here is a GoPro that's being put onto one of the vehicles, and so this is simulating what it looks like for the plates. But you'll get to take a ride here on the track system, and one of the things you'll notice here is we're going to the Verso store. So essentially, right now, a master compound plate is being put on to the system, and then we're going down the track, and we're able to bypass different workstations. So we have multiple Echo accesses integrated, and those are getting jobs throughout the day. And so some of those are available, some of them are not, some of them are down for PMs, but this solution essentially allows us to maintain operation throughout this process in a 24/7 environment, rather than just an 8 or 10 hour day while people are present. And so in wrapping up this section, I want to briefly just highlight how we at Lilly have been able to take this architecture that's been created around GBG and enabled synergy between not only our research and development space, but also through to our manufacturing environments. And so I'm going to turn it over to Kaveh to dive into this.
Thanks, Ryan. It's really nice to hear how some of the translational lessons can be applied to what we're doing in manufacturing.
So in the manufacturing environments, we want to use some of the same technologies that Ryan and his team have leveraged in the research space to develop robust assay platforms that we can deploy to all our manufacturing sites. And with that, we face some unique challenges. If we want to deploy rapidly and ensure that the platforms we're developing can be centrally managed, we have to ensure that our architecture is the same wherever we deploy. Our team also needs to ensure that the data interfaces they're specifying can stand up to the scrutiny of the regulatory agencies of the world. By driving global standardization of our assays, assay platforms, data systems, and data interfaces, the goal is that we minimize the effort and time of each deployment and maximize the return on each system developed. In the Global Robotics program, we've adopted a dock-to-dock strategy. Essentially what that means is for each stage of the manufacturing process, we want to develop or identify robotic solutions that drive us closer to a fully automated state. And that also includes our quality control laboratories. We developed a high-level roadmap of where we see our laboratories in the near future. We want to develop sample transport systems that transport material from production to our sample management systems, and then from our sample management systems to our test systems. Now, in order to choreograph this and ensure that we're driving the most value from our assets, we need some sort of laboratory automation management system. This system will essentially dictate the timing between distinct assets with their own control systems, ensure that the assays are being completed in a timely manner, and that all data is being sent to the correct place. We believe that Biosero has the expertise and that GBG has a unique collection of apps to potentially help us deliver on this vision. Starting at the bottom, we can use module agents to interface with our third-party platforms like Redknot, which is our standardized platform for RFC endotoxin testing, or GBG for work cells that are designed by Biosero. For sample transport systems, we can utilize the Transport Manager, which has existing drivers or magnet motion or autonomous vehicles from Mir and Onron. The sample management systems can also be interfaced using module agents. This connects everything to the higher level lab automation management system. At this level, we're scheduling the assays for the entire lab, we're collecting data from those assays and sending them to our LIMS systems. Our electronic lab notebooks are also sending the necessary data for specific assays. Specialized dashboards will also be utilized to inform lab leaders or operators of the status of particular samples, and data will also be stored in data lakes for future trending and analysis. However, developing standard platforms that we can deploy globally is easier in theory than in execution. Each manufacturing site has its own unique differences. For a particular assay, one site may be high throughput while the other is lower throughput, or one site may have more space dedicated for that particular activity than the other. For those reasons, we've decided to pursue a centralized or decentralized approach depending on the needs of the site. For a centralized system, we would connect multiple assay platforms to some material transport system that could be conveyor belt, autonomous vehicle, or even a person. That material transport system is connected to a sample management system, which acts as an interface between the production area of the site and the QC area of the site. Alternatively, in a decentralized architecture, we deploy the same assay platform. However, they are in their own distinct rooms and may or may not be interfaced with sample management systems. However, in both approaches, we can make use of the same assay platforms, data systems, and data interfaces. This approach allows us to develop solutions for both types of manufacturing sites with minimal deployment time. And if we ever need to scale up a particular assay, we just deploy another one of those platforms, knowing that the data interfaces already exist at the site. Now, in the manufacturing environment, there's decades of automation experience developing architecture similar to what I just described. Now, what you're seeing here is, of course, a very abstracted view of a manufacturing site architecture. Wherever you see a dotted line, that's meant to represent a data interface, and wherever you see a solid line, that's meant to represent a physical interface. At the heart of the manufacturing line, you have a manufacturing execution system. The responsibility of the MES is to communicate with all the different types of systems and equipment that are responsible for keeping the line running. This means that the MES, in one way or another, needs to be able to communicate its needs for material to an inventory management system that is then connected to an automated storage and retrieval system. And the MES also needs to be able to communicate in some way to a transport fleet manager so that it can transport that material from the ASRS to the manufacturing line. Directly, the MES needs to be able to communicate with individual work cells and the material transport systems that connecting them. At the time a sample is generated, the MES needs some sort of way to interface to our LIMS system so that it can generate the appropriate sample ID for that sample. So of course, it would make sense to leverage our decades of experience when it comes to developing automation architecture for lab automation as well. At the heart of the automated lab, you have a lab automation management system, which could be comprised of GBG, the GBG Order Manager and Scheduler, as well as data services layer. The lab automation management system is connected to our LIMS using a LIMS adapter, so it knows when a sample is generated and that it can expect it. The lab automation management system can then dispatch an autonomous vehicle to go gather that sample from production using the transport manager. It can then transport that sample to our sample management systems and communicate with those sample management systems using module agents. It can then schedule an assay to be run on our equipment using the GBG Order Manager and Scheduler, and when it's ready for that sample to be run, it can communicate with our assay platforms using module agents or GBG. For certain assays, where a portion of the sample preparation is done on a lab bench, we can utilize the lab experience tool to interface with our electronic lab notebooks or offline equipment. When our analysts or lab managers are ready to make decisions using that data, they can access it through our existing LIMS or through a custom dashboard. Pulling it all together, we want to standardize our data systems, data interfaces, and assay platforms, using tools like Green Button Go to simplify the process, all of which results in faster deployments, lower cost, and simplified support, enabling us to funnel information into global reporting, analysis, and business intelligence tools in a way that isn't possible today. And as a result, empowering our leadership and stewardship to make improved data-driven decisions.
Thank you, Kaveh. It's great to see how Green Button Go is leveraged in the manufacturing space in a similar manner to how we've used it in our research and development environments as well. To wrap up, I just would like to take a moment to thank many of our colleagues on the research and development side, those that are part of the Discovery Automation team, AME Automation, L2S2 Automation, our Global Sample Management team, and our Lilly Research Lab operations team.
And I'd like to take a moment to thank my colleagues in the Global Quality Labs in the Global Robotics Program, Corporate Engineering, Manufacturing and Quality IT, as well as Computer System Quality Assurance departments for all their hard work on these projects.
Thanks again to the Biosero team for the opportunity to present today, and also for the many, many hours that have been spent in making these solutions a reality for Lilly. And we also want to express our sincere appreciation to all of our hardware, software vendors and integrators that were part of the many systems that we highlighted and showed in today's webinar. We look forward to questions and answers. And we'll open it up to that now. Thank you very much.
Well, that was great, Ryan, Kaveh. Thank you very much. And we do have a couple of questions. So first question is, how do you store your data? Can you share the challenges that you faced and overcome?
So in the manufacturing environment, we store our data in a handful of LIMS or LIMS-like systems. Generally speaking, those interface and data systems are validated to be compliant with 21 CFR Part 11 compliance. And all the metadata associated with what is entered into the system is also recorded. So for instance, all the chain of custody information, who gathered the sample, who transported it, and who delivered it to a lab. And some of the challenges that we face currently are the current existing architectures in the lab automation space. So we want to move from a file drop architecture to more modern API technology so that we can ensure that data isn't manipulated between transfers.
Okay, and I have a couple more questions. What recommendations do you have for quality and security checks on data?
So, Ryan, I'll take this one.
Sure. Yeah. Or
we can. Yeah. So it's hard to check data once it's been generated to ensure that it hasn't been changed or manipulated. What you need to do is you need to specify an interface that you're using to handle that data, and then develop a validation procedure for that interface to ensure that data cannot be manipulated.
Yeah, and I think to expand a little bit on both of those questions, I think one of the reasons that we have been able to leverage Green Button Go across our research and development spaces is in this world, a lot of the LIMS systems, the ELNs, the data capture and repository places are all a bit unique or siloed to the particular area or division, or that's the preference of the lab. And one of the things that we've been able to benefit from with GBG, the GBG solution, is it really gives us that standardized place for in the way that we capture the data and where that data resides, at least initially. And from that point, it's just a series of APIs to connect it to a lab-specific LIMS or a area-wide ELN. But it gives us that standardized place where then we can take that data and we can start to answer questions about, the status of the instrumentation, the utilization of the instrumentation, the environmental data that David highlighted, and all of that stuff really paints the entire picture of how the process works. I think historically we've been used to having sample data, and then we have the analysis data, and that only gives you a snapshot of what happened along the entirety of the process.
Okay, great. I do have one more question, and it sounds like you partially answered it already, but with the kind of workflows that you described here today, how often do you need to handle disparate data, and what is your preferred approach to address those variances? We lock up? Oh, no, okay.
In our environment, it doesn't happen too much because our methods and processes are fairly locked down. We don't see a lot of variation in what we're doing. So generally, the data that we're receiving is specified, or the format is specified in advance, and it's validated.
Okay.
Yeah, and in the discovery space, I mean, one of the things that's very different than Kabe's area is instead of doing a high volume of samples and a low mix, we're doing a lower volume of samples, but a higher mix of the type of work. And so in addition to needing to capture that data, there's sometimes where we don't even know the questions that we want to ask of the process. And so having the ability to just capture all aspects of that data then allows us the ability to go ask those questions at a later time, and we actually have the information that then we can hopefully answer that. And I think that was one of the things historically that's been missing from the lab automation environment, is just we've automated things physically, but we haven't always captured all the data, and therefore 5-10 years down the road, you don't have the information there to satisfy the questions that may be asked today. And so that's a very important part to capture that. And also then in our spaces have the flexibility to be able to quickly adapt those workflows or protocols in an automated fashion, so that we can handle that high mix of different type of work. There's times where a project may only stay around for 3 weeks and then it's on to something else, and so we need the adaptability to be able to move at that speed.
Okay, great. Looks like we've answered all the questions. So Ryan, Kaveh, David, thank you very much for your presentations. And thanks to all of you for taking the time to be with us. But we're not quite done. If you want to move over to our Zoom meeting room, today's speakers will be available for additional questions and to talk shop on automation. That should be fun. The meeting link is in the chat window, or you can input the meeting ID that you see now in the slide. Thank you again for joining us today.